Hello guys, so we are back again, and in this session we are going to begin with the type 6 problems which you will see in limits indeterminate form. And these types, okay, this is not a means it is not in a form, okay, but it is just a type of problems in which instead of giving you letting you to find the forms or all these things, they will directly give you the limits and tell you to find the some random unknowns. Okay, so before starting with this session, I hope you have subscribed the channel so that we can bring some more engineering content which can help you boost your score. And don't forget to share this channel Omega Pi IDJ Gate with your friends. Now let's begin with the lecture. In this you can say type 6. What type 6 is? They will give you that limit value which you used to find in the rest of the 5 types of problems or forms, and then they will tell you to find the unknowns. Unknown can be anything, okay, you will come to know when you will come across questions. Unknown. Now what we will use, how to solve. We know limit exists, so we will try to bring it in 0 by 0 form and keep applying L'Hopital's rule until we get a fixed constant or finite value. Okay, so this is a particular path which we have to follow. They will give you that limit exists. One thing, if limit exists, okay, then we will try to put the values and say that it will be in 0 by 0 form. Then we will try to apply L'Hopital's rule and keep on continuously applying unless and until we get a fixed constant finite value, which we can say that this is the fixed value, so it should be equal to the value which they have given for limit, and then using that we will find the unknowns which they have given. Fine. Now let's begin with the questions. First question which we are going to see is as follow. The question says find the constant a comma b comma c if limit extends to 0, a e power x minus b cos x plus c e power minus x, the whole upon x sin x equals to 2. Now you have to write here they have given that limit exists and its value is what? 2 as mentioned. Then L equals to limit, let L equals to limit x tends to 0, a e power x minus b cos x plus c e power minus x, x sin x. We will put the value of x equals to 0 in the given problem. The moment I put, this will become 1, this will become 1, this will become 1, we will get a minus b plus c by 0. Now here what, x tends to 0, so denominator denominator x sin x tends to 0. Now for the limit, if this, okay, if it is not 0, if I say its value is a minus b minus c, then it will become constant by 0, which will become infinite. And now for the limit to exist, the numerator should tend to 0. Why? Because if it does not tend to 0, then it will become infinite, which is not possible, as they have given limit value as equals to 2. So if it becomes 0, it will be in indeterminate form, 0 by 0. So we'll write a minus b plus c equals to 0. This is my first equation. Now I know this is 0 by 0. Apply L'Hopital's rule. You have to mention all these steps properly. You will get limit L equals to limit to 0 a e power x plus b sin x minus c e power minus x, the whole upon sin x plus x cos x. If you put the values, you will come to know we get a minus c, and this will become what? 0. Again, what do we write here? X tends to 0, so denominator sin x plus x cos x tends to 0. Now for the limit to exist, the numerator should tend to 0, which gives me my second equation, that a minus c should be equal to 0. This will be my second equation. Now I have again came to know that it is 0 by 0 indeterminate form, because we have told that it is equals to 0. Apply L'Hopital's rule. What we get now? Differentiate this. What we are getting? We are getting a e power x, b cos x, c e power minus x, whole upon cos x minus x sin x. If I substitute the values, we are left with a plus b plus c whole upon 2. Now here we are get a finite value. Now so this finite value, now a plus b plus c, whenever finite value appears, we get the limit, so it should be equal to 2, which gives me a plus b plus c equals to what? 4. So this is my third equation. Now I want to find a, b, c values. How will I find? I know from this equation and from first equation that b is equal to a plus c, so it will become twice a twice c equals to 4. And I know from this that a equal to c, so it will be 4a equal to 4, a will be 1. If a is 1, c will automatically be 1. If a and c are 1, b equals to a plus c, so b equals to what? 1 plus 1 equals to 2. And then you have to write, so the values of the constant are respectively 1, 1, 1, 2. Now if you do all these steps and write them properly, you will get the complete marks. Now let's move on to the next question. The next question is as follow. Find constants a and b if limit x tends to 0, a sin square x plus b log cos x, the whole upon x power 4 equals to 1 by 2. here here they have given that limit. You have to like limit exists and its value is what, 1 by 2. Now what you have to write after this, let L equals to limit x tends to 0 a sine square x b log cos x the whole by x power 4. Substitute the values, substitute 0, you get 1, log 1 is what, 0, and this is what, 0, so you are getting 0 by 0, which is the indeterminate form. Now after this you don't have to mention any steps like x tends to 0, so the numerator, because you are automatically getting 0. So apply L'Hopital's rule. What you will get, 2a sin x cos x b cos x minus sin x the whole by 4x power 3. If we simplify this, we get sin 2x tan p. Substitute the value, you will get this value 0, sin cos. Okay, this will become what, 0, this will be 0, so we are again getting 0 by 0, which is the indeterminate form, right? So we will apply L'Hopital's rule again. Apply L'Hopital rule. You will get limit x tends to 0 cos 2x into 2 b sec square x the whole by 2l x square, right? After this what we are going to write? After this let's put the values. Here you will get 0, cos 0 is 1, so 2a, this will be minus b by, this will become 0. Now you have to mention the statement. As x tends to 0, so denominator what, 2lx square tends to 0. Now for the limit to exist, the numerator must tend to 0, which gives you 2a minus b should be equal to 0. So we got one equation. If it is equal to 0, then again I am getting 0 by 0, which is an indeterminate form. Apply L'Hopital's rule. Which will give you minus sin 2x into 2. This will be what? 2b sec x dot tan x the whole by, what will be, 24x. If we simplify this, we will get, this will be, 2 will get removed and we are left with 2a sin 2x. Here we are left with b sec square x dot tan x the whole by 12x. If I put the values, this will become 0, this will become 0, we are getting 0 by 0, which is an indeterminate form. We can apply now L'Hopital's rule. Apply L'Hopital's rule. What we get? Limit x tends to 0, 4a cos 2x into 2, which will become this thing. After this, what we will get is, here we will apply chain rule, which will give me b sec 4x plus b tan x 2 sec x dot tan x, the whole by 2l. If I simplify this, we are getting 4a cos 2x minus b sec 4x minus b tan square x 2 into sec square x, the whole by 2l, giving me, if I substitute the values, what I get, let me take the next page. I get minus 4a minus b, the whole by 2l. Okay, now we are getting some fixed values, and this will become 0 due to presence of tan square x. Now we are getting a fixed value, so 4 minus 4a minus b by 2l should be equal to the value of limit which was given 1 by 2. If I solve this, I have minus 4a minus b, this will be 6, giving me 4a plus b equal to minus 6. Do we have some relation between a and b? From equation 1, b I can write as 2a. So if I write b as 2a, this will become 6a, and this will be minus 6, giving me a equals to minus 1. If a equals to minus 1, b will be 2 times a, giving me minus 2. Now you have to write, okay, so the value of the constant are as follow, and then you will get the complete marks. Now let's move on to the next question, which is this one. Find constants a and b if limit x tends to 0, x into 1 plus a cos x minus b sin x, the whole upon x cube equals to 1. Here it is given that limit exists and its value is 1. Let L equals to limit x tends to 0, 1 plus a cos x minus b sin x, the whole by x cube. If I solve this, what I will get, if I put the values, what I get, this will become 0, this will become 0. I have 0 by 0, which is an indeterminate form. Apply L'Hopital's rule. We get if I put the values, I will be left with this will become 0. Here x square tends to 0, so denominator 3x square tends to 0. Now for the limit to exist, the numerator must tend to 0. After this step we will write that what if it tends to 0, it will be 1 plus a minus b should be equal to 0, giving me 1 plus a equals to b. This is my first equation. Now since they are equal, it is equal to 0, I am getting again 0 by 0. Apply L'Hopital's rule. what we get. What we are getting here is minus a sin x. Here what we are getting, a I will keep outside, minus outside, we will have sin x, then we will have x cos x. Here we will have minus b sin x, the whole by 6x. If I put the values, okay, if I simplify, a sin x minus a sin x minus a sin x minus x cos x minus b sin x whole by 6x, we are left with minus 2a minus b sin x minus x cos x, the whole by 6x. If I put the values, I am getting 0 by 0, which is an indeterminate form. I will apply L'Hopital's rule. Which will be last probably, because here we will get some finite value. So what we are getting, minus 2a minus b cos x minus x sin x. This will be, and here it will be plus cos x, the whole by 6. If I open this, we have minus 2a minus b cos x minus x sin x minus cos x whole by 6. Let's put the values and see what we are getting. If I put the values, I can see I am getting minus 2a minus b minus 1 by 6. This should be equal to what? This should be equal to 1, giving me minus 2a minus b minus 1 should be equal to 6. Finally minus 2a minus b should be equal to 7. And we have one relation already, which was what, let me see, b equals to 1 plus a. If I write b equals to 1 plus a, minus 2 equals to 1 plus a equals to 7, which gives me minus 3a minus 1 should be equal to 7, giving me minus 3a equals to 8, a equals to minus 8 by 3. If a equals to minus 8 by 3, b will be what? B we know is 1 plus a, 1 plus minus 8 by 3 giving me minus 5 by 3. So these are the values of the constant, and after this you have to write the question and then substitute and say that these are the values of the constant. You will get the complete marks. Okay, so if I have done any calculation mistake, okay, then sorry for that, but rest of all the things, okay, method will be same, that you will get 0 by 0 or you will get some constant which will be used for relation, and then you have to continuously apply L'Hopital until you get some finite value. So we are done with these problems. In the next lecture we are going to do some more questions on this, and then we are going to wind up the chapter. Thank you for watching this lecture. See you in the next lecture.